There are lots of other examples of collaboration. Capacity sharing in the way that O3B does is a good example. Sharing of open source is another wonderful example of collaboration and cooperation. Municipal networks, digital libraries, again, all of these are examples of people putting information into a common system and sharing it. People talk about information as power. Don't you believe it? It's information sharing that's power, and we're seeing that written large in the internet environment. There are also some big issues associated with the internet. When you operate on a global scale, but you have different jurisdictions, different cultures, different practices, doing things across national boundaries raise all kinds of interesting questions. So, we don't have a law of the net. We have a law of the sea. It took 20 years to put together, but we don't have one for the net, and we may need one. I also see questions like, well, what's a digital signature and what's the significance of it? If David Lassner and I carry out a contract online and we both digitally sign it and then I fail to meet the commitment, what does David do? I mean, where does he go and what jurisdiction does he press his case, and what's the significance of my digital signature or his on that contract? Unless there is some common agreement about that, it's not clear how he will resolve or how we will resolve that disagreement. And intellectual property, of course, is a huge issue in the digital world. I mean, the World Wide Web works by copying things, right? The browser goes to a website, pulls a file, and interprets it. That's a copy. And somehow that comes into great conflict with the normal copyright notion of not letting people copy things except under certain controls. So figuring out how to reincarnate copyright in the context of this online global digital environment is actually quite a tough problem. Well, I'm going to finish up with a quick summary of the current state of the interplanetary internet, which I've been talking about for 10 years, but now at last I can tell you that this has actually made a huge first step into space in just the last couple of months. In a way, this is a kind of an ultimate collaboration. The Deep Space Network is something that was developed in 1964 by the Jet Propulsion Laboratory. It's a big 70-meter dish system. There are 3 of them, one in Goldstone, California, one in Madrid, Spain, and one in Canberra, Australia, and they talk to spacecraft that are in orbit around the planets or landing on the surface like the rover did on Mars, the 2 rovers, which are still in operation. 10 years ago, my colleagues and I at JPL started thinking about how we would imagine a network capability like the internet being available for space exploration. What's important to us, and what is, I hope is important to everyone else, is that every time you launch another spacecraft, it would be nice if you could have access to other people's facilities, like the Deep Space Net, but also other spacecraft, so that if you needed to communicate, could have access to the assets of other missions, it would be very helpful. And the rovers are a good example. There are 4 orbiters around Mars right now. The rovers are relaying all of their data through those orbiters. They were reprogrammed to do that when the radio on the rover was unable to transmit all the data that was required back to Earth through the Deep Space Network. It was a 28 kilobit system and it overheated. So the engineers reprogrammed the rovers to transmit data at 128 kilobits a second on a different radio up to the orbiters, which grabbed the data and then held onto it until they got around to the point where they could transmit the data at 128 kilobits a second through the Deep Space Network back to Earth. The Phoenix lander, which landed in the end of May, also made use of this store and forward capability. Well, guess what? Store and forward networking is the way packet switching works. It's the way the internet works. So this is the Phoenix lander. It assumed that it could use store and forward capability in order to deliver all of its data, because at the North Pole of Mars, it didn't have access to a straight shot to the Deep Space Network. So we developed, well, first we thought we could use TCP/IP to do this. That idea lasted about an hour and a half. And then we realized, well, let's see, problem number 1, the distance between the planets is literally astronomical. And the round-trip time delays to Mars, for example, can range up to 40 minutes. Flow control with TCP does not work well with a 40-minute round-trip time. Then there's this other problem. It's called celestial motion. You know, these planets have a nasty habit of rotating. We haven't figured out how to stop that. So if you're talking to something on the surface, the planet rotates, and pretty soon you can't talk to it anymore because it's on the wrong side of the planet. So it's a very disrupted environment. We had to develop a whole new suite of protocols that we call delay and disruption-tolerant networking protocols. They've been implemented, they've been tested in tactical military environments, they've been tested with the Sami reindeer herders up in the northern part of Sweden, where they don't have very good satellite access because they're at 65 degrees north. And just this past October, we got access to the epoxy, I'm trying to remember the exact, no, the deep impact platform, which was used to launch a probe into a comet. About 3 years ago. The comet is long gone and or long past, and the probe is gone, but the main platform is still in orbit around the sun. And so NASA gave us access to that platform. We uploaded the new protocols, and we've been running the first leg of the interplanetary backbone on that spacecraft. We're going to upload the same protocols to the interplanetary or the International Space Station in June of this year, so I have another 6 months of testing there. At the end of that time, we will have space qualified the new delay and disruption tolerant networking protocols. We've offered them to the Consultative Committee on Space Data Systems, which standardizes space communication protocols around the world. And we hope that as a consequence of that, that every time a new mission gets launched in the future using these new protocols, those missions will be able to use previous assets that are out there and are still available and can be repurposed. So we will accrete an interplanetary backbone. Step one has already been taken to expand the internet operation across the solar system. Well, that concludes my formal remarks. I'm happy to take questions and answers. Thank you very much.